Part 3, Lecture Chapter 1. Now, let's look into measurement. You may be already familiar with some of these quantities: length, time, mass, and force. To measure such quantities, we use measuring instruments in a prescribed way in order to assign a number or value to that quantity. For example, to measure a length, we use a measuring instrument. For example, a mark meter stick to determine the numerical value we call the length. Other measurements may require more complicated instruments or more complex techniques, but the principle is the same. So the most important thing is you have to understand significant figures in measurement. So all measurements contains two essential pieces of information. First, a number, which is the quantitative piece, a unit, the qualitative piece. For example, the number 50 is somewhat meaningless without unit. Consider this. Daily wage, for example, RM50 per day. Weight of an eat, 50 grams per eat. And size of a square paper, 50 centimeter times 50 centimeter. Means that this number consists of unit as well. So this is the most important thing whenever you want to describe measurement. Must consist a number and also a unit. Significant figures in a measurement include the known digit plus one estimated digit. Remember, you have to have known digit and also one estimated digit. The numbers reported in a measurement are limited by the measuring tool. So it depends what types of measuring tools you use to get the measurement. Measurements by this method have inherent uncertainty or experimental errors. So significant figures relate to the certainty of the measurement. Note that as the number of significant figures increases, the more certain is the measurement. It is important that scientists correctly record the certainty of their measurement. For any measurable value, scientists only record all of the certain digit plus one uncertain or estimated digit. The uncertain digit is the last one on the right of the measurement quantity. So let's look into an example here. When we measure something, we can always estimate between the smallest mark. For example, the green object here, the object that you want to measure, this is your ruler, for example. So the unit for the ruler is centimeter. This is the object. So the length of this object is here. So we can make an estimation of 5. So we know that 4 is the known digit, 4.5 centimeter. But 5 is an estimated number. Let's say we use a better measuring device. So meaning that we can make a better estimation. Remember, the last number measured is an estimate number. So this is a ruler. The unit for this ruler is centimeter. So we know that the length of this object falls at this mark. So this is 4, we take 4, 4.5, this is a certain digit, 4.5. However, we are not sure the length of the object here, so we estimate it is 0.05 here. That's why we insert the length here is 4.55 centimeter, meaning that 5 is an estimated number. It falls here. So the certain digit here is 4 and also 5, 4.5. However, 4.55, 5 is our estimation digit. Let's look into this example. We want to determine the length of this paper clip. This is a ruler. So we are certain that the size or the length of this paper clip is 1.7 because this is 1. Okay, 1, 2, 3, 4, 5, 6, 7. But we know that the size of the paperclip is estimated here. So then we can do the estimate digit, which is 0.05. So the answer is 1.75 centimeter, meaning that 1.7 are certain digit. Meanwhile, 5, since it is an estimated number, so it is an uncertain digit. Right? So to explain better about this kind of measurement, the first digit, which is a known digit or a certain digit, it is 1. The second digit, known digit, it is 0.7. 1.7. Here, 1.7. The third digit, the estimated digit, it could be between 0.04 to 0.06. Alright, so the length reported is equal to 1.75 centimeter or 1.74 centimeter, or it could be 1.76 centimeter. Right? So known digits 1 and 7 here, the blue color digit, are 100% certain. The third digit, which is 5, is estimated number, so it is an uncertain digit. In the reported length, all 3 digits 1.75 centimeter are significant, including the estimated one. So all digits here are significant. So that's why the final answer is 1.75 centimeter. Don't forget the unit. Now let's look into example 1.5. A student records a measurement of 7.2345 meter. All of the digits are significant. Which digits are uncertain? So all the digits here are significant, but which one is uncertain? Alright, so okay, the number 7.2345 is a measured value that has 5 significant digits. Plan. The significant digit in a measured value always include one uncertain digit on the far right. Okay, on the far right. Okay. In the number of 7.2345 meter, the 7, 2, 3, and 4, 7, 2, 3, and 4 are certain, and 5 is uncertain. Right? So the reflection of this problem is every measured value contains one uncertain digit. The rest is certain. Always remember that the uncertain digit always on the far right of the value. Now let's look into how to write a measurement. A measurement should be recorded as number, space, followed by unit. Right? So for example, how to record the volume of burette 30.5 milliliter or 30.5 centimeter cube. So this is how we write a measurement: 30.50 space and then the unit, milliliter. Or it can be 30.50 space, centimeter cube as the unit. How to record the speed of a motorcycle of 90 km per hour. So this is how we can write the measurement. So it is 90 km per hour, or you can write it as 90 space kilometer space hour -1. Now let's look into measured number. What is measured number? It is an actual estimated reading, as shown by meters or detector of instrument. Measured number also can be estimated or can be read by visual accounts from calibrated or graduated equipment, for example, burette and pipette. And also, the measured number can be obtained from mathematical calculation, for example, average and also standard deviation. Measurements by these methods have inherent uncertainty or experimental error. Now, let's look into exact number. Exact numbers are called exact values because they are measured in complete units and are not divided into smaller parts. Exact number has absolutely no uncertainty in it and cannot be simplified and have an infinite number of significant figures. Let's look into the example of exact number. Number 1. Define numbers or the results of a count. For example, 37 people, meaning that the number of the people is counted, not measured. So we are completely certain how many people there are, which are 37 people. The exact number also could be conversion within the American system. For example, 1 pound equal to 1 ounce. Or conversion within the metric system. For example, 1 kilometer equal to 1,000 meter. The words per and percent, exactly out of 1 or 100. For example, 0.50 grams multiplied to 100%. So 100% is an exact number. Okay, just to add here, 0.50 grams is a measured number. Number 5, average denominator. For example, if we have A per B, so integer A is called the numerator and integer B is called the denominator. So denominator is an exact number. Here is exact number. Number 6 is constant value. For example, constant gas value, which is 8.3145 joule per Kelvin per mole. This is an exact number. Or Avogadro number, which is 6.022 times 10 to the power of 23. This is an exact number. So it is very important for students to understand and to know how to differentiate between exact number and also measured number. Okay, so we will look into the experimental errors in the next part of this lecture. Thank you.